Okay, so what will be the product for this next reaction? So this exercise in continuation with the last exercise. So you have E and now you have F. So if you have F, something like this, and if I treat with this HCl and in the presence of peroxide, so ROOR. So in the presence of peroxide, what will the product? Now, should we have anti-Markovnikov off? Yeah, good. In the presence of HCl, there is no anti-Markovnikov off. So hydrogen will go to the place where I already have more hydrogen. So hydrogen will go at this position, chlorine will go at this position. And this is a trick. You see, anti-Markovnikov off is only followed for HBr. Now Br will go here. Cl will go here. So let us write Cl. So Cl will go here at this position. Because in this case there is no anti-Markovnikov. I can write more if you have not able to write this one. So let us write the same thing again. So here you have a chlorine. Are you getting? So in this case there is no anti-Markovnikov addition. Because chlorine HCl does not give. Now let's Z. This says I have this compound, and if I treat this compound with PHCO3H, what will be the product? Now easy one this time. Now this is a paracid. What the paracid does? Give me the answer. What the paracid does? Oxygen insertion on double bond. So you will have to have insert one oxygen. So simple. So you can insert one oxygen here, and that is the final product. So this is simply oxygen insertion. Now next one. So let us discuss this one. What will be the product in this case? OSO4, osmium tetroxide, and now in the presence of OSO4 H2O2 OH-. If I simply take OSO4 H2O2, that's done. OSO4, what this does? This adds 2 OH group, and addition is sin. So you have to add 2 OH group, and you can add both from the same side. So OH you can add from the bottom side, and here also you add OH from the bottom side. Here you have a CH3, and here you have a hydrogen. You getting? Now see, this compound is basically, this carbon is chiral carbon, and this carbon is again chiral carbon. So you will have two products. This is one this is one product, and you will have another product, and in that case OH will be the upside. You getting? And both will be enantiomeric because optically inactive. Initially you have optically inactive, so finally solution has to be optically inactive. This means, and here I have OH that is on the top, here also I will have OH on the top, and then here I will have a CH3 that is in the bottom, and H that is on the bottom. So these two are basically racemic mixture. You're getting? So you will have enantiomeric mixture, or you can say racemic mixture, because solution will be optically inactive. Initially it was optically inactive, so finally it has to have optically inactive solution. Are you getting or not? Let us discuss the next problem. I think you have copied this one. Please keep copying fast, because these are easy problem. Okay, let us go for the next problem. So this is I. What this says, this is a KMnO4. This is easy one, everybody knows. If I treat with KMnO4, and this is a cold KMnO4, and also dilute, so cold and dilute KMnO4, and this is treated in basic medium OH-, so medium is basic. What will be the product? Again, this is the same as OSO4. You have to add, 2 OH group from the same side. So you can have the same thing the last time we have done. So you have to add 2 OH group from the same side. Either you can add 2 OH group from bottom side, something like this. OH group from the bottom side. Here you have hydrogen, here you will have CH3. This is one product you will get. Another product you can get if you add both OH from the top side. So here you have OH, and here also you have OH, and here you have a CH3, and here you have a hydrogen. So you can add both from the top side. Again you will get an enantiomeric mixture, no point to write. Now let us say And next one Z. So what this says, we have this. Now if you treat with per-acid, let us say CH3 acetic per-acetic acid, CH3COOH. If you treat this with an H plus and H2O, what will be the product in this case? Now the first step is easy one. You have to add a oxygen insertion reaction, because in the presence of peroxide you have to have insertion oxygen. Now the next step is epoxide cleavage in acidic medium. So just let us try. First make the epoxide, and then next step add H plus and attack water molecule. Finally, what are the product you are getting? Again, I will give you a hint that if you have a 3-membered ring opening will be in anti-fashion. So you have to add 2 OH group in anti-fashion. That is the final answer. You have to write down the mechanism. Let me wait for 1 minute. Okay, I think all of you have done. So first step is simply addition of oxygen, insertion of oxygen. So let us say insert 1 oxygen here, and here you have a hydrogen, here you have a CH3. Are you getting? Now next step, that is a hydrolysis. If you add H plus, so this oxygen take H plus, so you will have this CH3 OH plus hydrogen. Now the next step, if I break this side, I will have a carbocation this side, that is more stable. If I break this side, I will have a carbocation this side, that is less stable. So H2O will attack on this carbon, because I am getting more carbocationic character this side is more. So I can have H2O molecule, and this can attack here, and this can open. And now one important point here we have, and I can lose H plus, is important part is, now this is attacking and this is opening, so this is a ring opening. So this will happen in anti-fashion. Whenever you have a ring, 3-membered ring, you have a cyclic bromonium, halonium ion. In that case also attack is anti. So in this case, finally what will have, you will have this carbon that contains OH group, this carbon also contains OH group, but now these two will have anti-fashion. So final product I can write. So let us say if I write CH3 on the top, and here if I write OH on the bottom, then I have one hint, here I have to write OH on the top, because I have to have anti-fashion, and here I will hydrogen. Now again, if OH attacks from the top, I will have another product. Here I will have OH on the top, CH3 on the bottom, and here I will have OH on the bottom and hydrogen on the top. You getting or not? So this will be enantiomeric mixture, because initial product is optically inactive. So you will have enantiomeric mixture or racemic mixture. Are you getting or not? So you will get an enantiomeric mixture or racemic mixture. These two are basically enantiomer, because final product has to be have optically inactive. Are you getting or not? So let us discuss the next one. This is again easy problem. So if you treat with cold KMnO4, so let us say K. This time this is not cold, hot KMnO4. So if you treat this compound with hot KMnO4, let us write what will be the product hot KMnO4 if you treat with hot KMnO4 in basic medium. Now what will be the product? So can you give me the hint? Let me wait for 1 minute, and I will give you a hint. In this case I will have to break this bond, and now I'll do the same thing like ozonolysis, but only thing is in this case aldehyde will be further oxidized to acid. So if you break this one, this side will have a ketone, but this side will have aldehyde, but this aldehyde will further get oxidized to acid. So finally what I will have, this side ketone I will have no problem, but this side I will have acid, because aldehyde that is formed get oxidized to acid. Are you getting it? So I have to break this bond. This side I will have a ketone, but this side I will have a acid. If I have a reductive ozonolysis, I will have this side aldehyde. If I have oxidative ozonolysis, I will have again acid. If I simply use Hydrocarbon-4 OH minus in basic medium, I will have acid this side. You're getting or not? So let us copy this one and then we will do the next problem. Okay, so I think all of you have copied this one.